Hi, this is Nat. This is another MAT video. Today we're now going to do question 5 of year 2017. This is a question involving triangular numbers. Look at the question. He gives a sweep, the child C1, skips the child, gives it to C3, C6, then C0, and then so on. Explain why I is the last digit of these numbers. So basically, if you're doing this kind of clock arithmetic, then what you're doing is modular arithmetic. So if we draw a clock, no, this keyboard isn't working. Sorry, there is a small technical defect. I may have to fix it right now, and I might just tell you the answer right now. Because we're now doing clock arithmetic, then we are now using modulo 10. Yes, mod 10. And let's quickly write that down before we go insane. Yes, right. So, modulo 10. Wait. Modulo 10. Great. So, basically, what we're going to do is try to find the triangular numbers modulo 10. So, we have a circle of 10 kids. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So now we have a very inaccurate clock diagram of modulo 10. And so in I, the last digit on the number k plus 1 over 2, basically we're just trying to find the triangular numbers mod 10. And this is what we're trying to find in the question. Let 1k18 explain why the k at 20 minus k minus first sweeps again to the same child. So let's calculate this. 20 minus k minus 1, 20 minus k over 2. So we are going to take away k plus 1. So I'm going to increase the pen size a bit so that you can see a bit better. Equals to 20 minus k plus 1, 20 minus k over 2 equals to 400 minus 40 k plus 1 plus k plus 1 all over 2. And guess what this is trying to tell us? We are now going to say very safely that this is k plus 1 over 2 plus 10. Yes, 10. 20 minus 2k plus 1. There, since we are just adding multiple of 10, this means that, and this is a very big that means they are going to be given to the same child. Yay! So all we need to do is explain why the k suite is given to the same child as the k plus 20th suite. This is basically trying to tell us that the triangular residues, very similar to the quadratic residues modulo 10, repeat in a period of 20. So I am going to, after this video, I'm probably going to analyze the paths of triangular residues mod n and probably classify them in front of you in the description. Well, so the good thing is quadratic residues mod n always repeat in a period of n, or sometimes n over 2 when you're dealing with n equals 4. But that's not the point. What's the point is that we're now going to solve the question. Yeah. Wait, sorry, quadratic residues, about that, it's going to repeat at a period of n over root m. So it's going to repeat n over root m, where the modulus is km. Got that? So, explain why the k suite is given to the same child as k plus 20th suite. This is basically trying to tell us that 20 plus 1 over 2 is divisible by 10. It's 210 equals to 10, 21. Coincidentally, the 20th triangular number is the 4th primorial. Interesting. Which children can never receive any sweets? So we're going to calculate the triangular residues mod 10, and they are 1, 3, 6, 0, 5, 1, 8, 6, 5. And then we have, so 1, 3, 6, 0, 5, 1, 8, 6, 5, 5, 6, 8, 1, 5, 0, 6, 3, 1. And then 0. So this is our period. So which children can never receive any sweets? So basically, these are the children which are not in the triangular residues list. 2, 4, 7, and 9. When the teacher has given out all the sweets, she has walked exactly 183 times round the circle. I bet the teacher has a lot of sweat. And given the last sweet to C0. How many sweets were there initially? It's simple. So 1830. So what we're going to use, well, we can solve a quadratic equation, but even better is to use the triangular root function. Yes, this is the triangular root function. And then we're going to plug in 1830. And then this answer, we are going to get 121 minus 1 over 2 equals to 60. So there were 60 sweets initially. And which children received the most sweets? And how many did they receive? So that means we need to look through the triangular residues list again. So there were 3 periods of 20, which gives us 60. And so we have 1, 3, 5, 6, 8, and not. Not only appeared 1, so it's 3 times. 1 appeared 4 times, so it's 4 times 3 is 12. 3 only appeared twice, so 6. 5 appeared 4 times, so 12. 6 also appeared 4 times, so 12. 8 also appeared 2 times, and it's 6. So that means C1, C5, and C6 had the most sweets. Yep, they had the most sweets. And how many did they receive? 12. Now this is very interesting because compared to a previous question I did in an earlier video, at least the children don't have diabetes. So, thank you and see you in another MET video.